twice before, once with Alan Sommerskog in the front seat and once with Hugo Cornelis. And they were like constantly like, excuse me, that's not entirely accurate.
That's where I end up harassing people a little bit, saying, I'm trying to give a present. It's like Andy did. I'm trying to give a presentation here. Will you shut the hell up?
And on that note, I think all of us are going to shut up and let you take it away, Jeff.
Thank you very much. And in case you didn't realize by now, this is GroupBy 2021. Today is not enough coffee yet for me. October the 27th, and this is the European version. And you've seen this a couple of times. And Catherine has gone through this. Be nice. If you can't be nice, go away. Sponsors, super important. We have Redgate and SolarWinds are the core sponsors. Redgate, SolarWinds, and SQL Server Solutions Group are our media sponsors. The Minionware, the folks at Minionware are virtual group sponsors. And I forget, what was the name of the other sponsor, Daniel, that you were talking about?
Data Masterminds.
Data Masterminds, and behind the scenes, Born SQL. And so we're going to continue on. Welcome to the Black Arts Index Maintenance. This is actually a whole series of presentations that I'm putting together. This is 1.2, and that's not version 1 or version 2 of item 1. It's actually 2 presentations rolled into one that normally take 2.5 hours. I tried to boil it down to 1 hour, and this is going to hurt your heads, folks. We're going to talk about GUIDs versus fragmentation. While that sounds like a very tired old subject, you got to trust me on this. It's not, because that GUID fragmentation that occurs, they're not the problem. We are. We're the ones that make it happen. My name is Jeff Moden, and you can see my email address up here. Here's a little bit about me. I am the fellow that coined the term rebar, and yes, it is pronounced rebar, not R-bar. The reason why I pronounce it rebar is it reminds me of the metal rods that are stuck in cement forever and not going anywhere fast. And that's also true of any rebar code. I also help make the tally table. You might know it as a numbers table, but I helped make that a very commonly used item. A long time ago, it was considered to be a very advanced technique that not many people got. And I have to tell you, SQL Server is not only my profession, but it's also my hobby. And I do it pretty much to the exclusion of everything else, except breathing and drinking coffee. And I know that means I need to get a life. But as you can see on TV here, I have a face for radio, so I'm kind of stuck doing what I'm doing. As for questions, please hold them all to the end. I promise you will not be disappointed every time I've given this presentation. Everybody, halfway through, I stop and people ask questions like Andy Yoon pointed out. That'll be answered in the second half. So if you can, if you want me to reference something in particular, please include the page number. All right, so what are we going to talk about? Let me ask you this. What is your first thought when I say the word GUID? All right, that's a nasty little 4-letter word that most people think of. And did you actually think of things like all the incredible uses it offers, the incredible insert performance due to no hotspot? How about the ability to merge multiple sources with no collisions? Did you even come close to thinking about its ability to easily absorb expansive updates? Or did you think of what most people think of? And that would be massive fragmentation. All right, why do we think this? The answer is because we've all seen thousands of demonstrations that supposedly prove it. And you know what quotes mean, folks. All right, so how do they prove it? Well, typically they'll run code. Now some GUID demo code that looks like this and some identity demo code that looks like this. And they have a table, each has one column in it. On the left, we have unique identifier and new ID, which of course means random GUID. And over on the right, we have a nice ever increasing index using identity. And of course, they put the clustered index on those 2 columns. And then they hum around in a loop 100,000 times, inserting 1 row at a time. And then they come over here and they say, here's the results. And they have code to check for GUID fragmentation, code to check for identity fragmentation. They're both reading from sysdmdb index physical stats. And if you say that 3 times before your first cup of coffee, you're a linguistic wizard. And the only difference between the two is which table they're looking at. And then they show you the comparisons, which are the results from these things. And we have 2 frames here. The top frame is for GUIDs. The bottom frame is for ints. And the first thing they'll do is they'll hum you all the way over here onto the right. And they'll say, looky here, compare the sizes. Ints are good, goods are bad. And then they'll take you over here and they'll show you fragmentation and they'll repeat that. Ints are good, goods are bad. And if you're lucky, they'll take you over here to average page space percent used. And again, ints are good, goods are bad. But if you look at that, goods are bad. Goods are so bad, why isn't that at 50% or less? And I got to do something to my screen here. Hang on just a minute. There we go. Now I can actually see. Why isn't that at 50% or less? And the answer is, you already know, if you have a page that's partially full, it could actually continue to be filled. It's the way all indexes work. But that should be a strong hint that there's something wrong with this test. And nobody ever looks at it that way. And it caught me, and I was part of all that started this. So what's missing from that test? And the answer is reality. It's nothing like real life, folks. They take an empty table, they jam 100,000 rows in it one at a time, and they say that's a test. There was no index maintenance. And guess what? The size of the pages, the size of the test, it doesn't even qualify for index maintenance. And yet they have the nerve to say, okay, look, fragmentation is bad. Okay, it's not. We'll see why. There's no mention of other types of indexes either, like zip codes, names, hash codes, phone numbers, even customer IDs. They all have some really serious problems with fragmentation. It's not just goods. But, and it's also a myth continued by misinformation. For example, if they did do best practice index maintenance, what would it actually do? And the answer is everything expected. It would reduce fragmentation to well below 1%, and then the GUID index will very quickly fragment again, and they all go, see, I told you. We all know this is right? How is that misinformation? Because they never correctly identified the true cause of the fragmentation. What is the true cause of the fragmentation? Like I said in the beginning, it's totally us, and we're going to see why. So a couple of objectives here. First of all, this isn't for rank beginners. We've got a time constraint, and I can't give you all the good stuff about goods that people typically avoid. And there's some stuff you need to know about SQL Server. And so I have to assume that you already know a fair bit about goods index and index maintenance. And I also have to unteach you on some of these things. And also in SQL Server in general, you need to know what a log file is and how it operates. At least be aware that it's a problem, and you need to know a little bit about recovery models like the simple bulk logged and full recovery models and what some of the differences are. 3 primary objectives. Number 1 is destroy the myth of GUID fragmentation. Why am I picking on GUID fragmentation? Because it's actually the poster child for fragmentation. If we can fix that, we can fix just about anything. And so at the end of this presentation, we'll see that we successfully insert millions of rows into a GUID clustered index with less than 1% fragmentation and no index maintenance, quite literally for months. In the process, we are going to lay waste to best practice index maintenance. We're going to prove it's not a best practice, that it was never meant to be a best practice, and that using it causes some serious damage and not just to your goods. And we're going to learn a much better way. So there's a couple of more things. We're going to not only demonstrate the fix for GUID fragmentation, but we're going to bust some index maintenance log file myths. We're going to prove reorganized, not your friend there. A lot of people say, well, for random goods, the fix is new sequential ID. Yeah, probably not, and we're going to prove that. We're also going to talk about expansive updates and how they just absolutely kill your ever-increasing new sequential indexes, and how random goods will actually prevent fragmentation there. Just a quick sidebar, because people ask, expansive updates are where you've done a whole bunch of inserts, and then you turn around and you do an update to some of your variable width data types and actually make them larger, which causes the row to grow, which makes them not fit anymore, and it causes a page split. We'll do a deep dive on that here in a little bit. And tons of ancillary information, including a new tool that will actually allow you to see an index that I built. And if you haven't seen it before, it's kind of a remarkable output. All right, so we need to start off by comparing a really good tool against a really bad tool, right? So we're going to talk a little bit about the comparisons between identity and random goods. So first of all, let's talk about an ever-increasing index, which is an identity. And we have a whole bunch of pages here. Most of them are full. And if you look at this last page over here, it's typically partially full. And when we do inserts, it'll fill up that last page because the inserts are done in order by the index. And when it runs out of room, it's going to make another page, and then it'll do more inserts. And then it runs out of room and it makes another page, and you end up doing more inserts. And those are known as good page splits because they didn't have to move any data. That's basically the definition of a good page split. So for inserts, only the last pages might be in memory. That can be very good or very bad. There's no page splits here. That means no fragmentation. And if you look at all these pages, they're all naturally filling up to 100%. And so there's no index maintenance required. And so everybody says ever increasing indexes are the best, right? Yeah, well, you may not think so in the future here. Random goods for inserts, possibly all the pages are in memory, all of these. I'm just showing you the leaf level here, folks. If those pages are full and we do, even if we insert one more row or do an expansive update of just one byte, maybe, all those pages will instantaneously split into other pages. And I say instantaneously tongue in cheek because it's actually quite computationally a very long period of time, and it'll beat the hell out of it'll cause a huge amount of blocking. And you'll see why here in a minute. Not only that, but it causes an instant doubling of space used and a bunch of other things. But I want you to start thinking here. This is why everybody thinks GUIDs are bad. Start thinking, what would make those pages full? And everybody goes, well, God, Jeff, we're adding data. Yeah, I know that, but is there anything else that would make them full? For example, could index maintenance make them full? And then while you're thinking about that, if you look up here now, what happens if we were to insert more rows now? Would we actually get more page splits? And I'm not going to answer any of those right now because you'll come to the right conclusions. I want you to start thinking about it. Put on your water-cooled helmet. So let's talk about some good things about GUIDs. Let's talk about an ever-increasing index again. And again, all the pages are full and the last page is partially full. There's no fragmentation, no index maintenance, but we have this nasty thing called a hotspot at the end. And we're going to run through that again, except this time I'm going to apply a narrative about how it works. Here we go. Ready? Slow, 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 slow. All right. Each section has to wait its turn to do an insert, and there's an extra wait for the pages here because you can't write to a page that isn't there yet or is in the process of being built. That makes for some wicked slow OLTP. And if you look at these pages now, if you were to do an expansive update now, you have the same problem as doing a GUID. Expansive updates kill, and it all blocks selects. And guess what? You know, people say, well, use new sequential ID instead of random goods. New sequential ID has this same and other problems. Okay, so it's not the magic bullet that a lot of people are going to think about. Let's look at random goods. Let's look at them in a different way. First of all, there's no end of index hotspot. There's no waiting on inserts or updates because there's no contention for one page. It weathers expansive updates. That means no page splits, and that also means no fragmentation. And I know what you're thinking. Wait, what? We are talking about random goods here, right? The answer is yes, we are. If you take a look, as long as and we got this from the previous page where I wanted you to start thinking, as long as there's enough room on a page, an out of order insert or expansive update will not cause a page split. So we can insert new rows and do expansive updates out of order, or we can blast them all at once. And so long as there's room on their pages, there's not going to be any page splits. All right, so think about that too. All right, so what's the purpose of index maintenance? And it's much more than just removing fragmentation. Here's the first reason everybody knows this. Logical fragmentation really only matters for sequential read aheads, otherwise known as range scans. Frequently, it doesn't fix anything. And on OLTP systems, it makes absolutely no difference. Every row is searched through the B tree. It starts at the root, goes through the intermediate levels down to the one page that you want to look at in the leaf level. And that happens every single time. It doesn't matter what you do, you can't change that. If you want to look up one row, it's got to find the page that it's living on and read it. If it's in memory, that helps, of course, but that means that if you have an index that's 99% logical fragmented and another index that has no fragmentation, it's not going to matter. There's not going to be any performance difference whatsoever for single row lookups. It only matters if you're doing, reporting and other BI things like aggregates and things like that. And here's a pretty good reference on reorganize and rebuild indexes. All right, physical fragmentation. This is actually more important. It's also known as page density and average percent of page fullness. I want to remind you the minimum that you can read is one logical read, and one logical read equals one page. I also want to tell you, just on this as a little bit of a sidebar, because I see people going through some really strange calculations. If you know the page count, all you need to do is divide by 128, and I'll give you megabytes, because there's 128 pages per megabyte. Now, before pages can be read, they have to be loaded into memory, like I was saying, just as they appear on disk. If they're only half full, you're wasting half your disk space, and more importantly, you're wasting half your memory. If not for this problem, you'd never need to defrag and index on an OLTP system. Purpose number 3, everybody knows this, but they forget about it. And even those that don't forget about it seem to do some weird stuff with it. And I'll explain what that means here as we go along. First of all, a bad page split occurs in the middle of an index. Paul Randall wrote a great article over on his site on sqlskills.com, where they take, they're 4 to 43 times tougher on the log file than good page split because of the data that they move. So here we have a leaf level of an index. It's only got 6 pages in it, and they're all filled to capacity, and they're all in physical order right now. The thing that puts them into logical order is they're doubly linked. Every page knows where the next page is and where the previous page was. And if that logical order matches the physical order, there's no fragmentation. That is the definition of fragmentation. Does the physical order match the logical order? If not, you have fragmentation. People also say order doesn't matter in a relational database. Heck, it doesn't. When you get ready to do an insert, SQL Server is going to look at that particular row, figure out where it belongs in the index according to the sort order, identify the page where it's going to put it, and put it there. In this case, and everything that we're getting ready to talk about is fully logged here. In this case, we decided, or SQL Server decided, hey, it's got to go on page 3, so it starts a system transaction which can't be broken by anything else, including another system transaction. And it says, hey, page 3 incoming. Page 3 goes, dude, I couldn't eat another bite. I'm sorry about the bad joke, but you got to suffer with me. Anyways, this is logged, and SQL Server says, okay, no problem. It expands that transaction to the next logical page, which is also the next physical page in this particular case, because there's no fragmentation. That expansion is also fully logged. And then it has to either go find an existing empty page, or it has to create a new one. And once it's put its hands on an empty page, it has to break the links between the original 2 pages and then create pages between those 2 old pages and this new empty page. And then it has to move about half the data from page 3 to what we'll now call page 3A. All of this is fully logged. And then finally, we get to add a new row. I say finally, again, tongue in cheek, because that's not the end of it. We added the page here. And so that means that in the next level up in the B tree, it has to add a page number to one of those other pages. If that causes a page split, it does the same thing at the next level up, except the next level up might cause blocking on hundreds of pages, depending on the sizes of your index. And that might cause a page split, and it could go rippling all the way up to the root level. And if it does page split on the root level, you're now blocking the entire table. And this is what happened to me in January of 2016, and why I ended up going 4 years without doing any index maintenance. I don't recommend that. It was a great experiment, but anyways, that's why I did it. So we got the system transaction. None of these pages are released until the transaction commits, and this is blocking everything: inserts, updates, deletes, and just everything. When it finally commits, pages 3, 3A, and 4 are now part of logical fragmentation, because although they're in logical order, they're no longer in physical order. And pages 3 and 3A also suffer from physical fragmentation. Some people call this, I think, internal fragmentation. It's confusing. I don't call it that. Physical fragmentation or page density problems, because they're no longer full. So what's the problem now that we know what page splits are? What's the problem with GUID fragmentation? And the answer is we drank the purple Kool-Aid, and we keep using best practices that aren't, and were never meant to be best practices. Here's what everyone thinks is the best practice. I say everyone, please. Those of you out there that aren't using these as best practice, no hate mail, please. Everyone means like 98% of the world. All right, so it says, yep, between 5 and 30%, we're going to do a reorganize. Go over 30%, we're going to do a rebuild. And everybody thinks this is the best practice because of some very unfortunate wording up here at the top. It says, use the following table to determine the best method. All right, so like my grandma used to say, Jeff, we got a little fly poop in our pepper here. We got some footnotes, and if we take a look at the footnote that appears just below this documentation, we find some stuff that either people read and ignore because they understand the meaning, or they never read it. It says right here, these values provide a rough guideline. How can a rough guideline be the best method? It's not, okay? It even says so right here. The actual values may vary from case to case. What's a case? Every index is one case. These numbers may vary for every single index. Nobody ever looks that way. Where those numbers come from, this is the link of where they used to be, and I'll explain why I said that in just a minute. And they were created by a fellow by the name of Paul Randall. You may have heard his name a couple of million times. So many people asked him about it. He actually wrote an article about it. And in that article, he explains, Microsoft held a gun to his head and said, we and our customers need some sort of a standard practice as to where to get started. And so he wrote those and said, he made them up, but they're based on best practices for where to start. The last two paragraphs say it all, though, folks. He says in the second and the last paragraph, yeah, those numbers, they're not set in stone. They're a big generalization. There are a ton of other factors that may affect your choice. And the final statement says it all, folks. The final statement in his article. In the meantime, take those numbers with a pinch of salt and don't treat them as absolute. Ladies and gentlemen, you don't need a magic decoder ring to figure out that means don't treat them as a best practice, because they're not. He also says he wishes Microsoft would have updated the old paper that all this was written on. Well, they finally did. On April the 20th of 2021, they removed the previous page from the documentation and replaced it with this. And I'm not going to do a deep dive on this, but I'll start off. Here's the link for it. It's the same as before, but they have this index maintenance strategy thing here now. Do not assume that index maintenance will always noticeably improve your workload. That's very true. That will always be true. Then they talk about measure the impact, do A/B testing, there's a link for that. Do this observation, monitor this, that, and the other thing, establish a correlation between fragmentation, page density, and if determined, and yada, 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 yada. They don't tell you how to automate any of this. It's all based on one or more workloads, and they don't tell you how to correlate the workloads to your individual indexes. So most people in the world are going to reject this as too difficult or too much time spent on it. And what they're going to do instead, they're going to go back to what they already know, this, even though it's wrong, and we're going to prove it's wrong. So something else in the documentation, almost everybody misses this. We're looking at SysTM index physical stats documentation here, and there's a paragraph called evaluating disk space usage. And that paragraph is a very unfortunate, or title is a very unfortunate name. It has a section here. I'm not going to even come close to reading that. You need to go read that because it's a great introduction to fill factor and out of order inserts. If you haven't read this before, read it. It's simple and it'll help you out a lot. But what it really should be titled is, here's how reorganize actually works, because it says alter index reorganize will compact an index by trying to fill pages up to the fill factor that was last specified. They missed the word up, and we'll prove that up is needed. They also say, note that alter index reorganize cannot reduce page fullness. Ladies and gentlemen, that means that it doesn't operate according to your fill factor. It fills things up to the fill factor, and it will not clear the space out above the fill factor like a reorganized does. And it says right here, instead, an index rebuild must be performed. All right, I want to introduce you to index DNA, which is what I call my stored procedure and the spreadsheet that helps us look at indexes. Over on the left-hand side, page density from 0 to 100%. That little blue cross right here, yeah, that's a single page. That's that end of index, partially full page that we've seen so far. It's 63% full, and you can tell that just by going back over to the page density axis and looking at that. We have page numbers across the bottom. These are not page numbers. These are just the logical order of the pages. You could get a size just by coming, going down and getting an estimate of the number of pages and dividing by 128, but you don't need to do that. If you take a look at the legend and this area in the upper right-hand corner, and we zoom in on that and talk about that a little bit. Once again, page density is blue crosses. What's that blue line up there? It's actually a whole bunch of blue crosses real close to each other because of a perfectly rebuilt index. We have the rolling average here. It's a rolling average of the previous 200 marks. It's that skinny red line that's also trapped up there. It's quite horizontal right now because it's a perfectly rebuilt index. And we also have the linear trend line, which is the dotted line here. We'll see all these separate later on. There's a hidden purple box here and a hidden purple line that actually goes all the way across. That's for average page density. And remember, I said you don't need to actually calculate or estimate how much data you have, how big it is, because the average page density is calculated out for the current size in megabytes. There's also this black box and the black line. You can see the black line go all the way across. I'm currently using that for the actual fill factor. And that target size also is based on the target page density. And then we also have a section here where the difference between the two will be expressed as either a cost or a savings. If it's cost, this is actually a line. You can only see the arrowhead. It'll be red. If it's savings, it'll be green. All right. And excuse me. We have the sample rate here. It's saying 1 to 1. That means every single page on this million row table is shown in this chart. We'll also see that it'll cough up the table and index names, and I have a little demo for you. Let's go over to here. And I'm using the Stack Overflow 2013 database that Brent Ozar does for downloads in a lot of his classes. And this line right here, I'm declaring a variable, and then I'm calculating the object ID for the table, which happens to be the post table that I want to examine. And then, yeah, I call it SP index and index DNA. I normally don't use these prefixes, but this is one I do use it on because I actually do put this in the master database. It'll work in any database, but I put it in the master. And so I say, okay, exec SP index and index DNA, and you have to give it the object ID of the table, and you have to give it the index number. For clustered indexes, it's easy. It's always 1. For non-clustered indexes, you have to determine the actual index ID and put it there. But it gives us 2 results. The first result that it gives us, if we look up here, it'll actually give you the server name instead of the token that I put out here. If you click on the upper left-hand corner, it selects everything in that output, and then right-click and say, copy with headers. And so it copies all that stuff. And then we go over here to the spreadsheet that I also include in the zip file. And you click on that first blue box. By the way, the instructions are right here. If you click on this first blue box containing the server name and paste that header in, it fills in all that information. And you can see it also filled in the server name and all that kind of good stuff right there. If I type a comment in here and press enter, that'll also go up here so you can make comments if you want to. And if we go back over here and click in the upper left-hand corner of the second output to select everything, right-click again, hit copy with header, go back over here to our spreadsheet, go to the second blue box and click on it and then press paste. Ladies and gentlemen, this is what the pages on that index look like. We have a 100-to-1 sample rate, but look at the very low page density all over the place. And just as a little bit of a sidebar, this is after both a rebuild and a reorganize. There is something really wrong with this index, and no matter what you do to it, it never has an actual page density higher than about 83%. What's wrong with that index? It has in-row lobs, and that's another presentation that I do called Black Arts Index Maintenance 3, and I tell you how to fix this. One of the other things I want to show you is this target page density right here. If you go up here and change that, you'll see target page density move, and it also recalculated the sizes here. And it's saying if I could rebuild this to 97%, I would save 4.4 gigabytes on this. All right, so enough of that. That's how you use index DNA. Going back over to here, this index is in really good shape. All the pages are filled in the same amount because we just got done rebuilding. And it's actually, it contains 1 million rows of random GUIDs and some other stuff. We're going to insert 10K rows at a time and see what the results are. We're going to use this chart here to keep track of where we're at. Right now, we're at the very start. It has virtually 0% fragmentation, and it has an 82.3 page density. That's the way things work. When you do a rebuild, every SQL server says, do I have room on the page? And if the answer is yes, it says, okay, if I insert a row here, if it fits on the page, it's going to put it on there, even if it goes slightly over the fill factor. And that's why it's at 82% instead of 81% where I rebuilt it at. All right, there's a couple of things I want you to watch. Above the fill factor, watch for pages filling up. Watch the area below the fill factor for page splits. And we're getting ready to do an insert. So watch this on 3, 2, 1, point. Now look at there. This is working beautiful. This is how an index should work. Okay, we filled up all the pages across the board, and there's no fragmentation there. And oh my God, this is wonderful, right? Let's do it again. Let's see what happens. Another 10,000 rows and boink. Look at there, it's working great and no fragmentation yet. Let's do it again. Boink. All right, this is working great, but we finally have a page split here. Let's insert another 10,000 rows. And there we go. And now you can see we've got 3 additional page splits. And this is all output from, each one of these is a run from index DNA that I just happened to overlay to make this movie. All right, so we got a few more iterations to go, and I'm going to do them in rapid succession. So watch it. Here we go. All right, so there's 50,000 rows, 60,000 rows, 70,000 rows, 80,000 rows, 90,000 rows, 100,000 rows. And ladies and gentlemen, we've reached a critical point. What's that critical point? We have now gone over 5% according to the best practice rules. And at this point in time, I want to point out, we did 100,000 rows to get to 5%. Those other tests are not like real life. This is what real life of a GUID should look like, not the other stuff, okay? And so we can also see page density started going down. It was increasing, and then we have enough serious page splits where the page density started to go down. And the other critical point that we're at is the area above the fill factor is actually pretty full because we are getting page splits now. All right, so we are between 5 and 30% logical fragmentation, and according to the best practices, it means it's time to reorganize. Yeah, let's see how well that works. You're in for a shock, okay? Here we go. There's a couple of things I want you to look at. First of all, look at these 3 circles. They each have a page in them. Look at this one circle. It's got 3 pages in it. If you look at this skinny little area below the fill factor, it only has 2 pages in it. And if we look at the area between the area of fragmentation and our fill factor, I'll call that the no man's zone. Look at that. And one other thing, look at the average page density. It's at 88.0 here right now. So I'm going to do the reorg in 3, 2, 1. I'll do that one more time just so you can see it because it's fun. Here we go. There we go. All righty. So a couple of things that changed. If you look at that skinny bar, we now have a whole lot of pages in there instead of just the 2 that were there. Where did those pages come from? They came from down here. because reorganize is trying to do page compression. It's trying to compress these pages up towards the fill factor. Look at the no man's zone here. Where did those pages come from? They came from down here too, from compression. Same thing with these 3 dots. Those pages are no longer there. They got moved closer to the fill factor, as did one page over here in this other dot. So what we end up with is fixed logical fragmentation. We are well below 1%, just like I said, everything expected, right? But page density increased. We really needed it to decrease. And the reason why it increased, if you look at the average page density here, it didn't clear anything out of the area above the fill factor like a lot of people expect it would. It doesn't follow the fill factor, folks. It does page compression up to the fill factor. It doesn't make any extra room. So we end up with still a ton of low density pages. The area above the fill factor is not only still full, but it actually got fuller. What do you think that is from? Again, reorganize cannot make new pages. It compresses pages up to the fill factor. It will not make space above the fill factor. And it, worse than that, it removes any free space that fragmentation caused when we needed it the most. Okay, let's see how this works out. This is that same 10-row chart with a couple extra columns, and we're going to make it a little bigger here. And by the way, apologies to my green colorblind friends. Most people don't realize it, but 1 out of 7 men suffer from a form of green color blindness. And I didn't realize, I finally found a site that shows me what the colors look like. They can't see this yellow because red and green in RGB are what make yellow, and they can't see that yellow. Anyways, we'll fix that someday in the future. Reorganize gets stuck very quickly. You know, after that one fragmentation or reorg that we saw, it takes just 2 more days to get to 7% fragmentation. And then after that next reorg, 2 days to get to 10%. And then it gets stuck in doing daily reorgs. And you can see the percentages are going up. And then all of a sudden, the percentages start going down. Yay, right? Is fragmentation decreasing? Yeah, not really. We keep inserting rows into our table, so our table keeps getting larger and larger and larger, but the number of rows that we're inserting is a fixed amount. So that fixed amount is becoming comparatively smaller and smaller and smaller. And so it makes it look like fragmentation is decreasing. We're actually making a mess of things. Instead of waiting 2 days for some pretty nasty fragmentation, let's do something a little different. Let's do a rebuild at 1%. And I know what everybody's thinking. Damn, Jeff, you're going to be rebuilding about once every 15 minutes. Not true. Look at this. Dun, dun, dun. Look at that. We went 8 days to get to just slightly greater than 1% fragmentation. And if you look over here, we have a problem with our reorganizers. We started out at 37. We did page splits, 1,104 page splits, as a matter of fact. And here's what we do for each one of these reorgs. We did 9,781 total page builds due to page splits and inserting of data here. Over here, 221 for 8 days. And then after that, for the other 4 days, just 1. We only did a total of 222 page builds. Reorganized, because all of these were stuck and reorganized, cost 44 times more pages than rebuild did. And the rebuilds, you can see, we had 221 page splits, and then we allocated data. On the page splits, we were doing page splits, and then we did compression to remove the pages that were just built. Really, really bad idea, folks. And remember, the rebuild, we started at 8 here. This is 2 days longer than what the reorgs did. All right, some long-term fragmentation studies. We're going to compare the best practices versus this new low threshold rebuild thing we just discovered. In the test, I have test tables that consist of a GUID column that is also the clustered index. It's a unique identifier. Folks, don't ever turn your GUIDs into varchar or nvarchar. It just doesn't make sense. You're talking about 36 or 72 characters plus 2 bytes for the varchar size. Don't do it. Leave them as unique identifiers. We'll try to sort them. And it also has a fluff column as a char 100. Even if those are null, they occupy space. And that gives us 123 bytes. That's 16 bytes plus 100 bytes. That's 116 plus 7-byte row header. And this is the actual size that gets reported in SysDMDB index physical stats. There's a little bit of a sidebar. If you take 8096 and divide it by that 123, that gives you 65 and change, but you can't have a partial row. So that gives you 65 rows per page for other calculation purposes. And yes, 8096 is the correct number. Each page is 8192 bytes. It has a 96-byte header. That leaves 8096 for data, your row header, and the slot array. 8060 is not correct here. 8060 is a, shall we say, an implicit value for the maximum row length that they imparted on us. It's not the actual capacity of the pages. All right, the test parameters. I wanted everything to be exactly the same, so I created a 3.65 million row table of random goods, and I preserved their order with an identity column, okay? And so every test uses the same random sort order, except for the baseline. I used the same 3.65 million goods, but I pre-sorted them in GUID order. So they're kind of like sequential ID and kind of like an identity column in that they're ever increasing. I also did no index maintenance tests like everybody else did. Best practices tests, we do them, do nothing until we get up to 1,000 pages. And then even then, if it's less than 5% fragmentation, do nothing. Between 5 and 30, we do a reorganize. Greater than 30, we do a rebuild. I did that for these 4 fill factors for both daily checks and possible defragmentation weekly. We're not going to go through all this. We don't have time, but you won't be disappointed in what I show you. And then the low threshold tests say do nothing until we go over 1,000 pages, just like everything else. And then the rules totally change. We'll go over 1%, do a rebuild, no questions asked, never reorganize. And I do it for the same fill factors and the same type of test. All the tests follow this flow chart. We insert 1,000 individual rows per simulated hour, for 10 simulated hours per simulated day, for 365 simulated days, for a total of 3.65 million rows. At the beginning of each day, we zero out all our counters and store that into a table. And then we jump into our hourly counter. We insert 1,000 rows in a very rebar fashion like everybody else does. I record the insert duration. We're not going to cover that in this presentation because it takes too long. But at the end of every hour, I measure and record not only the fragmentation, but the page density, the number of pages, and a whole ton of other pieces of information. And I do that for 10 simulated hours per day. And at the end of each day, for our purposes for this presentation, I measure the fragmentation, ask if it qualifies for defragmentation. And if the answer is no, then I don't do any index maintenance. And I just record how long it took to measure the fragmentation. If it does need index maintenance, then I'll use one of the 3 different types of index maintenance for whatever test we're doing. And that again gets included in the duration and a bunch of other things. I also count the number of daily log file entries and the actual size in megabytes for the daily log file entries. And then we come over here and we bump the counter, and everything that's in yellow and orange gets recorded at the beginning of the next day. And so that's how the program works. Let's take a look at the baseline. This is a slightly different chart. It's based on the results of the test that you saw there. We have a page count of the leaf level for our x-axis. I'm sorry, for our y-axis. And our x-axis is just the day number. Each vertical line here is 1 week. There are 77 plot points per week because there are 7 days, and we have 1 plot point at the beginning of each day plus 10 plot points for the hours. That's 11 times 7 is 77, and the test is a year long. This diagonal line is the baseline. Some baseline facts, that's that pre-sorted ever increasing goods like that I told you about, like an identity column. It has 0 bad page splits, 0 fragmentation, and it needed no index maintenance. This only contains good page splits where data was added. Some more baseline facts, except for any completely vertical lines that you'll see here in a bit. Any line that has a slope steeper than this baseline is because of bad page splits that cause fragmentation. We'll see that. In fact, we'll see it right now. This new line is the no defrag line. I call this the Brent line because it was inspired by Brent Ozar, who said, you know, you're wasting your time rebuilding indexes. And he was partially correct. This is that's why I went 4 years without doing it. Anyways, it's steeper than the baseline due to bad page splits. And some facts about it: no index maintenance was done. It was like all the other tests: 99% fragmentation, 68% page density, constant rate of page splits all day, every day. There were no bad page splits here. This has got bad page splits every single day. It has a 68% page density. And so I would ask people, gee, how much memory am I wasting? Everybody goes, well, done, Jeff. 100 minus 68, that's 32. That's actually grossly incorrect. We're actually wasting 46.5. Memory, because those extra pages, that extra page space, that's got to be counted too. So if you take 100 and divide it by that page density, subtract 1 from it, multiply that times 100 to change it into a percent, we are wasting 46.5% more than what we need to. How much do we need to? The data that has no bad page splits is considered to be 100%, and you can see 46.5%. All right, here is the best practice line that we just drew up here, this kind of sawtooth looking line here. It's riddled with page splits all day, every day. Let's take a look at these 3 weeks and zoom in and see just how bad it is. We can see the sudden drops in that line are due to reorganize, removing free space when we need it the most. If we move the baseline up closer to that, we can see the angle of those lines, the slope is much steeper than the baseline. And so, you know, those are all due to bad page splits. Here's the ironic part, folks. If we move our no defrag line is not as steep as these lines. Doing index maintenance wrong is worse than doing no index maintenance at all. You got to take that home to the bank because you're going to need to rely on it, okay? And if we look at just this one day here, all 3 of these values, we see the no defrag line had 261 page splits. Our best practice line had 451 page splits. My God, our baseline was 156. That's only good data. Look at how many page splits. Subtract 156 from each one of those, and you can see how many bad page splits you actually have. And I want to remind you, this is just for one small index. My God. If we look at the first 5 weeks, it looks like we got something swirly going on there. Let's zoom in on that, take a look. And oh my God, we get some crazy lines here. We did no index maintenance on this until the first 1,000 pages, so it followed the same line as no index maintenance. If you look at the points where the red arrows are, that's where the reorgs occurred, and you can see we very quickly get stuck doing reorgs. These flats, what are these? These were fascinating. We didn't stop inserting data here, folks. We stopped allocating pages. That flat line means we didn't add any pages. Okay, and let me show you why that's important. Right here, if we were to look at the data, we did a rebuild. It took a quarter second and a whopping 50,000 rows. Okay, and then after that, we went a day and a half with 0 page splits, almost 2.5 days to get to 1% fragmentation, but we didn't quite make the 1% fragmentation. And so at the end of the 3rd day, we were above the 5% threshold, and we had to do a reorganize. Watch this, folks. Reorganize took more than 2.5 seconds and more than 250,000 log file rows. Ta-da! Isn't that wonderful? What did we get for our efforts there? The next day, 420 page splits instead of just 142, and we went to 23%, almost 24% fragmentation. Didn't quite make 30%, so we did another reorganize. And the time came down, but we're still doing over more than 250,000 log file rows. what did we get for that? Another day of massive fragmentation. This time it's twice as bad. We had 918 bad page splits. Mercifully, we go over the 30% and we get to do a rebuild. The rebuild only takes 130 milliseconds, and 50,000 log file rows isn't looking so very bad anymore. For that, though, if you notice, we went a little bit more than a day and a half. It always gets longer for 0 page splits. We made it almost to 3 days at 1%, but we didn't, and it wasn't quite at 5%. So we went another day, which gave us a reorg at 11%, and then we're stuck in the page splits all day, every day. Just totally miserable. Okay, so we know the reason why the best practice line is jagged here. It's riddled with page splits all day, every day, and now we know the cause. To summarize, reorganizes the cause. And it, like a bad drug, it's dangerous because most people, it doesn't work the way most people think it does. And it does nothing to prevent fragmentation. Even worse than that, it actually is the cause of page splits all day, every day. It is not a best practice. It's not even a good practice. So far as I'm concerned, it's a worse practice, okay? How do we fix this? Low threshold rebuilds at 1% instead. The politically correct term here for PFM is pure freaking magic. We're going to make it so that all the page splits of fragmentation virtually disappear from our random GUID index. And we're going to do that by this 1% fragmentation and rebuilds. Remember what the flats are, okay? Remember what the flats are. Here we go. I'm going to change this line to a nice straight dash line just so that it doesn't confuse anybody. Here we go. Here's low threshold rebuilds for GUIDs for a year at 80% fill factor. Oh, sorry about that. Look at this. Remember what the flats are, ladies and gentlemen. That's 0 page splits for weeks at a time. That means 0 index maintenance for weeks at a time. And if we look at that same 3-week session where we were doing reorganize, it was doing reorganize once every 3 days, and it was suffering from pretty bad page splits all day, every day. If you look at that, I don't even need to zoom in on that. You can see there were virtually no page splits. We did 1 rebuild in 3 weeks with almost no page splits at less than 1% fragmentation, except right when we did the rebuild, which was at 1.04%. You have to go all the way back here to get to 1 rebuild every 3 days. Here, 1 rebuild a week. And if we look up here, ladies and gentlemen, we inserted 10,000 rows per day for 32 days for 320,000 rows with less than 1% fragmentation. And now do you see why I say those other tests had nothing to do with reality? They don't show you reality. If you look at this little memory triangle, the hypotenuse is where the best practices was. The rest of it, except for when a rebuild occurs, we're always using less memory than rebuilds, and we're actually doing something. We're preventing page splits. If we take a look at the end of run status for the best practice and the 8% low threshold, you can see that we did a sample here about 4 days after we did a rebuild. Let's go see what index DNA looks like. Okay, so at the end of the test for best practice, look up here. It's chock-a-block full above the fill factor. No wonder it's doing page splits all day, every day. If we take a look at our low threshold rebuild, this is what it looks like after 4 days, okay? Now, we have room to grow. After 4 days worth of no fragmentation, I'll actually go out to 36 or 37 days because it's always getting better because the index keeps getting larger. No fragmentation after 4 days, no page splits after 4 days. It started out at 0.017% fragmentation and stayed there for 4 days. And I know what you're thinking, Jeff, are you blind? You have pages below the fill factor. What's going on there? Well, we actually have 12 pages there. Guess how many CPUs I have? 12. And so when you do a parallel rebuild, each segment of the parallel rebuild will have a partial page at the end, just like you saw when we did our end of page inserts, where the end of the index has a page that isn't quite full all the way. Excuse me, I need a quick little sip. So this is actually pretty good. Those pages are just the end of segments. There was no increase in page counts. There was no fragmentation. All right, here are all, and with them all, I said, they're not all, because I didn't do the 100% here. Don't ever do index maintenance on something that's 100% full is just stupid. And I'll show you why. But we have 70, 80, and 90%, and you can see the legend there. Again, I got to do some consideration for some folks that have green color blindness, and there's a lot of them. So I'm going to point these small steps here, they're about a week apart. That's the 90% fill factor. I'm going to recommend that you don't do those for at least 2 years. Don't use 90%. Here's our 80%. We saw that before. Let's take a look at our 70% line. Ladies and gentlemen, we went 58 days inserting 10,000 rows per day. That's more than 500,000 rows, and we never even got to 1%. Again, those other tests, yeah, they didn't go far enough, okay? And if we look, we didn't quite get to a rebuild here. In fact, we were 1 day before a rebuild. Let's go take a look and see what the index DNA looks like there. And this is what it looks like. And you can see we didn't have very much fragmentation for going 8 weeks here. And most of the area above the fill factor got used. Now, people say, fill factor, you're wasting space. All right, let me ask you a question. Why do you make your log file bigger than it needs to be and you never shrink it every single day? And the answer is to prevent unexpected growth. And this is exactly what you're doing with fill factor, okay? If you're doing it correctly, you are preventing unexpected growth in the form of page splits. And page splits, just like growing the log file, is painful. And so it's a very worthwhile investment. For all you folks out there preaching that fill factor is bad, please stop it because it's a very worthwhile investment, especially for goods. All righty. All right, log file myths. 2 prevalent log file myths. Let me check my time here. Come on. Okay, we're getting close to being out of time. I got to finish up here. I'm sorry.
Jeff, technically you have 75 minutes.
Yeah, I know, but I'm trying to do it because I want to give people time to answer or ask questions if they have any.
Well,
So,
there's a 15-minute buffer thereafter, so you actually do have a little bit of breathing room.
okay, all right, thank you. 2 prevalent myths. Reorganize always uses fewer resources than rebuild, right? And rebuild is always much worse for things that depend on the log file, like AG and stuff like that. We shouldn't do rebuilds, right? We should always do reorgs, right? All right, let's see how right that is. We're going to look at something called that's using bulk log, 80% fill factor, bulk log recovery model. And this is the first 6 weeks of one of the tests. And over on the left-hand side, this is the number of lines in the log file. The x-axis is the day number. And these spots here, those are where rebuilds occurred. All the other peaks are where reorganizes occurred. Okay, and if you notice the flats after these 3 rebuilds, yeah, that's a good sign. All right, and most of the rest of this is due to reorgs. If you look over here, it looks kind of flat, and this is where we didn't do any index maintenance. These are only the number of log file entries due to good data going in. So, and that's very constant all the way across, except where we do reorgs. This green line is our low threshold line. And so let's get rid of our supposed best practice line and take a closer look at this green line. At the beginning, we're doing rebuilds because it gets to 1% every single day. That's the nature of goods. And this is where a lot of people also quit because they look at that and they say, well, that's a trend to do it every single day. They don't go far enough, okay? Just even in the first 6 weeks, we go to once every 2 days, once every 3 days. And before the end of 6 weeks, it's once every 4 days, okay? And it gets much better than that afterwards. So best practice, not a best practice here. And the reason why is because you've got to stop using reorganize in best practices. And I want you to remember, reorganize not only didn't do anything good for you, but it did a whole lot of bad things for you. It perpetuated page splits all day, every day. All right, so here's our first 6 weeks that we just saw down here in the lower left-hand corner. Let's look at what the rest of the year looks like. Oh, Lordy. reorgs every day, reorgs every second day, reorgs every third day, reorgs every fourth day. And if you take a look over here, you see that one point, that last reorg? If you go over to the left, it was more than 3 million log file entries for the reorg. And that's just for one index. And worse than that, you paid that huge price for reorganized to pretty much screw you with page splits. It not only didn't work, but it hurt you in the process, okay? And guess what rebuilds did? And if you can't see it, I just added with the reorg or the low threshold rebuilds at the very bottom. It's this little green line down here at the bottom. We started out doing rebuilds once every 3 days here. It worked up to once every 6 days here, once a week here, up to 2 weeks here. And we can finally start to see the lumps and bumps here of where they actually occurred. And I want to remind you, we were at less than 1% fragmentation between each one of these. And there were virtually no page splits between each one of these. And compare that to the 3 million scale over here, folks, right? Good Lord. This rebuild, this one rebuild right here, it was an offline rebuild. It took about a third of a second. Everybody looks at it and says, 63,000 log file entries. That's horrendous. No, go back and compare it to what the reorgs did. It was almost 3 million log file entries there. All right, let's look at full recovery model. The full recovery model looks remarkably the same. And the reason why is because reorganize on all these best practices, it's always fully logged, okay? So we have the same problem in every recovery model with reorganize, and it's going to be stuck in reorganize all the time. If we look at our this one little rebuild way down here in the lower right-hand corner, because we're in the full recovery model and became fully logged, it took a whopping almost a second. And oh my God, 123,000 log file entries. Yeah, compare that to almost 2.8 million. That's crazy. How about, okay, everybody says, okay, number of log file entries don't matter. What about the space used? All right, here's the space used. The best practice is your red line here, and the green line here is your low threshold rebuilds. I don't even need to explain this. It's self-explaining. This is the 1 gigabyte line right here for reorgs. Compare that against the rebuilds and what happens in between. Oh my God. Reorganize used a whole lot more log file space, and it crushed you. Remember, it kept doing page splits all day, every day. And they say, reorg is less resource intensive? I don't bloody well think so. What about full recovery with online rebuilds? Ta-da! Here's what that looks like. The reorgs didn't suddenly get better. We've had a massive scale change here. You can see that's still at 3 million rows. Everybody looks at this and they go, oh my God, the online rebuilds are horrible. They took 9 seconds and almost 8 million log file entries. All right, calm down, folks. Take a look at this. Let's check out the number of reorgs between these two rebuilds and see what happened. That was a total of 65 seconds. It doesn't really matter because it's online. And people say that, but it's not sitting there quiet. It's using CPU time as well, folks. So this matters as well. It took between that, all the reorgs, made 22, almost 23 million log file entries. It ran every 4 days. And I want to remind you, it perpetuated page splits all day, every day. And that's just for one small index. What happened between these two rebuilds? For rebuilds, they went almost a month with no page splits, less than 1% fragmentation, and no index maintenance. That was worth our 8 million log files compared to 23 million log file entries. Good Lord. So my recommendation in order by performance, if you can, use bulk log offline rebuilds. They're nasty fast and very, very low resource usage. If you can't, in other words, like you have standard edition or your 24/7 rather, then use full logging with offline rebuilds. And if you can't use that because of standard edition, then this won't help you. If you have enterprise edition, use full logging with online rebuilds if you can. For you folks that are stuck in the standard edition, you're going to say, well, that's justification for using reorgs. My God, no. You're just making a mess of things. We proved that doing no index maintenance is better than doing index maintenance incorrectly. And if you're using reorganize, there's a really good chance that you're doing it incorrectly. It's better not to do any index maintenance than it is to do it wrong. Now, for GUIDs, you can use reorganize if you want to compact in-row lobs, but then do a rebuild immediately afterward to repair the damage done there. And lobs are a whole nother session. That's in section Black Arts Index Maintenance 3. But consider other indexes. It's not just GUIDs here that have a problem. Any place where you lower the fill factor to try to prevent fragmentation is going to suffer the same problem here. Reorganize is not going to clear the area above the fill factor. You're going to have exactly the same problem. So there's one place where even reorganize isn't going to hurt you because it's so screwed up. We'll see that here in just a minute. But remember, reorganize, not a good thing to use, folks. It has its uses. This type of thing is not one of them. All righty, so new sequential ID. I want to touch on this just a little bit. People recommend using new sequential ID instead of random GUIDs. And they say it solves everything about GUID fragmentation. Yeah, let's look at that, okay? Just like me, I'm getting older. It depends. Features of new sequential ID. They're similar to the old type 1 GUIDs. Now, in case you don't understand the ramifications there, that means there's security risk because they contain the MAC address. That's also what makes them really, truly globally unique, okay? Unless you're using VMs, and then you could have 2 VMs that end up having the same MAC address, kind of. Other issues, they change sequence at the beginning of every restart, not always ahead, contrary to popular belief. And sometimes they go behind. They're not contiguous, they jump ahead every 10,000 rows. Paul Randall did a test, said 1,000. I actually did a test, it's once every 10,000. Or at least on my machine it was. Only works as a column default. You cannot say select new sequential ID and get a new sequential ID. It only works as a column default. That means that it still requires a second trip to get to the latest value, just like an identity column would. And it's got all the same problems that an identity column actually has, including page splitting due to massive expansive updates. Still, it's best for merges because of that MAC address if you can tolerate that bit, that security risk. And you know, some people will tell you, yeah, it'll help prevent some non-clustered index splits. Not as many as you think, because what you're doing right now with identity columns, yeah, that's also causing splits. Just not as bad as random GUIDs in some cases. So my recommendation is you can read this on your own. Yeah, use it only if you need to be guaranteed to have collision-free merges, and even then you got to pay attention if you're using VMs. So otherwise, don't use it. Expansive updates. We kind of talked about this. We need to see it even more because GUIDs fix this. Okay, so conventional wisdom is if fragmentation occurs, lower the fill factor. So let's see how well that works on identity clustered indexes with expansive updates. Definition of an expansive update is anything that causes a row to grow in size. This applies to all in-row variable width columns. Some classic examples are a modified by column, a status column. A couple of hidden examples are the out of row pointers for lobs. Yeah, those are actually expansive because they go from null to some value. Microsoft made a big mistake there. A little bit hidden, row compression, which is also included in page compression. That changes all your fixed width decimals and a whole bunch of other types to variable width. And so it can really put the screws on row compression. So here's an ever increasing index, and let's talk a little bit about it. A common processing method is we're going to insert new rows, and because it's an ever increasing index, they're going to go in at the end of the index. We're going to process those newly inserted rows, and part of that process means we have to update them to mark them as processed. And typically people will do that in a modified by column. They'll also sometimes add comments, and both are a really big mistake. Fragmentation occurs because of that, and they lower the fill factor to, in this case, 70% to try to stop it. So here we have a table that contains 90,000 rows. It used to be this big at 100%. Now it's this big because, and this number is actually, it's more than 40%. It's more like the calculation is 42.8%, almost 43%. And let's see what happens when we insert 1,000 rows or 10,000 rows. And it's going to look like this index gets shorter. It's not. It's going to do a scale change. You'll see this 2,000 change to 2,500. Here we go. This is what an insert looks like when we're done. And it looks like Donald Duck's beak or Daffy Duck's beak after an accident with Bugs Bunny. You can see that the new rows went in at 100% despite what the fill factor says. There's only one time that a fill factor matters during inserts, and we're not going to cover that here. Every other time, they're going in at 100%, folks, because they just go in until the page is full, and then they do a new page fill. A good page split, as they say. So we have 10,000 rows here. We're going to update only 333 of them. In other words, 3.3% of those 10K rows with a modified by to say we're done. And you can see something's going to happen, and boom, massive instant fragmentation. And again, instant is tongue in cheek because computationally that takes years. Okay, only 2 pages weren't affected. All this area above the fill factor that we had, it's totally wasted. Okay, it did nothing to help prevent our fragmentation here. And on top of everything else, since it has 42% more, our logical reads or scans are going to increase by about 40%. And so we've reduced the performance of our scans in a bad attempt to try to prevent fragmentation. And then you also have to ask yourself, what data are most queries going to concentrate on? And the answer is on the data that we just inserted and updated. What's that look like? Yeah, it's 50% full. So everything that we're looking at here is wasting half our memory now. And you can't afford to do that very often. And guess what? New sequential ID, because it's ever increasing, has all these same problems. Okay, so you're taking something that can prevent fragmentation, random goods, and you're converting it to new sequential ID, which is almost going to guarantee fragmentation if you do updates. Okay, properly built, maintained random good would not have fragmented. We kind of proved that by doing inserts. People say random goods have a fragmentation problem. No, there's one other thing here. In 2019, they came out with this thing for to help the hotspots called Optimized for Sequential Key. Okay, first of all, it doesn't fix the expansive update problem. It doesn't do a single thing for it. And in fact, it's a type of insert throttling and scheduling. Pamela Hood wrote a great article about it, and this is on that article. She also included a link here, which is what people used to do before this happened, and it's actually a better fix in my opinion. 4 of the 6 methods that they talk about here to get rid of the hotspot recommend changing to non-sequential keys. Guess what method 4 recommends? And it might not be such a surprise to you at this point. They recommend using a GUID. But again, we got a little problem here. If you look at the note here, it says, hey, this will cause frequent page splits, low page density, and so on. That's because they don't know how to maintain goods, okay? We busted that. This is beautiful. This is a great method for preventing the hotspot. It'll also fix the expansive update problem where that other thing, yeah, no chance. So quick review. Reorganize, it makes a mess of things. It's more brutal on the log file than you thought. You should never use it as a general defrag on random goods. And remember, goods aren't the only things that this affects, okay? You need to look at your other indexes and say, really, I'm gonna really reorganize that? What's that gonna screw up? So my recommendation, even if you're using standard edition, is don't use reorganize except to compress lobs and then follow that up with a rebuild. New sequential ID, yeah, my recommendation is don't just, it's not a panacea, folks. Don't use that to get rid of fragmentation with goods. Learn how to maintain your goods correctly. That will get rid of all the fragmentation except once every 58 days after a year. New sequential ID is security risk, got all the same problems as an identity column. The only advantage, and it's even worse than an identity column because it also has the disadvantage of being 16 bytes wide instead of 4 or 8 bytes wide. But again, up to the requirements, just don't treat it as a panacea. It's not, it's going to cost you, seriously. We learned the secrets of random goods. Use a lower fill factor. I'm going to recommend that you use a fill factor of 71 or 81. I call random goods type 1 indexes because I end the fill factor with a 1 to say, hey, I need to do low threshold rebuilds at 1% here. Whatever you do, don't use reorganize to maintain random goods. It's just going to kill you. You know, you're going to be tempted and you're going to say, I need to do something about fragmentation. No, leave it alone if it's a random good. If you can't rebuild it, do not reorganize it. You will kill yourself. Random goods aren't the problem here. We are, okay? And we saw that if you're using the currently worldwide accepted best practice index maintenance, in other words, you drank the purple Kool-Aid, and this is not limited to, but especially for goods, then you're probably doing it wrong. Good fragmentation is really a myth, and we proved it several different ways. It's a myth perpetuated by bad demonstrations, misinformation, and we used a random good to prevent fragmentation during expansive updates and inserts, out of row inserts or out of place inserts. If you can do that, it'll handle expansive updates. And we pretty much proved that random goods are actually the epitome of how we think indexes should work. If you lower the fill factor, it helps you prevent fragmentation. Okay. All righty, that's it for me. Any questions?
It's been fairly quiet except for people thanking you for this session. But we do have one question. I think most people are just staring while you are presenting this engaging session. The one question that we have in the chat from Thomas is there a rule of thumb how to set the fill factor for optimal rebuild times or timings?
No, that's very simple. Remember I said when we were talking about the best practices, and I said, what is a case? Each and every single case is one index. There's no optimal way to figure out the fill factor. There are a lot of people that have tried, and you end up rebuilding indexes a hell of a lot more than what you really need to. And you really don't need to rebuild them that often. For goods, the optimal is rebuild with a 1% threshold. For a lot of other indexes, and like I said, this is just the beginning of an entire series. I actually have code that I'm using at work that I'm not ready to release yet, that it goes in and it figures out what kind of index that you have. Remember I said optimal fill factor? What's the optimal fill factor for an ever increasing index that you do updates on? The answer is, it's actually 97%. The 7 is like a footless 2 to identify. There's no chance of fixing this. It's type 2 where it's broken, you just need to recover disk space. And you need to go back later on and fix that. You need to figure out how to prevent fragmentation. So the answer is no. There is no optimal panacea type fill factor. It just isn't there. And for God's sake, don't change your default fill factor to something like 90, not even on good type databases like SharePoint and stuff like that. Don't do that. You're just killing yourself. You need to evaluate your indexes and how they're fragmenting. No simple fixes. Any other questions? And if the answer is no, I'm a little surprised. Excuse me. Andy will have an appreciation. A great question is one that has already been proven. And a lot of people at the end used to ask, okay, you're inserting 10,000 rows per day. Well, what happens if you insert more rows than that per day? And the answer is, it's totally self-scaling. It is a panacea. It's pure proportional mathematical magic if you have a fairly consistent insert rate. Let's take a look. You've seen something like this before. Okay. Looks very familiar, slightly different up here. And it's also different here. This is what happens when you insert 100,000 rows per day instead of only 10,000 rows per day. You can see the page count, it's 900,000 instead of 90,000. What I want to point out is it's proportional. It still has a 32-day period here, except the 32 days is now 100,000 rows per day for 32 days. Ladies and gentlemen, this inserted 3.2 million rows with less than 1% fragmentation, and our 70% over here, yeah, it did the same thing. 58 days here times 100,000 rows per day. Ladies and gentlemen, almost 6 million rows with less than 1% fragmentation. And now do you see why I'm yelling and screaming about those other methods and those other tests that people did? And I'm sorry if that's politically incorrect or if it sounds like harassment, but good Lord, we've all been misled for 22 years on both GUIDs and on index maintenance. This will continue to get better for any consistent rate. It'll look almost exactly like this for 10 rows, 100 rows, 1,000 rows, 10,000 rows, 100,000 rows, 1,000,000 rows, 10 million rows. If the insert rate is fairly consistent, you'll always get a pattern that looks like this. So my question to all of you is, does anyone in the room still think that random GUIDs are actually a fragmentation problem? My answer is not only no, but hell no. All right, so that's it for GUIDs and fragmentation, a little bit different than what you've probably seen in the past. They're not the problem, we are. My name is Jeff Moden, and I also want to say, you know what? Time off is very rare for people in IT, and you're taking some time, either work time or time off, to listen to me rant for an hour here, or a little bit more than an hour. And so you're making a difference. I want to thank you all for what you do, for coming to things like this to try to learn something different. It might not be perfect, but it's different and it'll get you thinking. There's also a ton of extra info at the end of this. You can go look at that. And the if you go back to the very beginning real quick here. Come on. Try it again. There's my email address if you want to contact me. I've included the index DNA spreadsheet and stored procedure in the zip file that gets included in this. But if you have any questions, you can contact me at jbmail@gmail.com. And yes, that is a burner. I only look at it about once a day. So be patient with me, and it will get back to you. That's it for me. Thank you very much.
Thank you, Jeff. You're getting a lot of great feedback in the chat as well, ranging from Daniel, who says he has ammunition for the next time he needs to discuss fragmentation and rebuilds, to Jessica, who says that she learns a little bit every time you speak. And Surgeon saying his head hurts, but in a good way. So I think we can all agree on that.
Even though I've seen this content before, I always like watching it again because it's always a good refresher, because it's so dense, because there's so much material in here. It's like, oh yeah, I forgot about this. Oh yeah, I forgot about that. This is a session that you got to rewatch a couple of times to really absorb everything.
Oh, thanks, Andy. And that's also why it looks like I'm reading off the slides, and in some cases I am. The reason why is I hate it when you go to a presentation and they have 6 bullet points and they talk to it for an hour. And when you go back and you look at the slide deck, you have 6 bullet points and no explanations. I want people to be able to take the slide deck and play it back. And I don't write PowerPoint presentations. I try to write PowerPoint books. And it also helps folks that are a little bit hearing impaired when you're flashing that stuff up on the screen in the lesson method. So thank you very much for the feedback, folks. I appreciate it. And you can tell I had a little fun.
Yeah, the session was recorded. So if you do need to go back and play it back at a slightly lower speed, you can do that as well once it's published.
Thank you. Alrighty, that's it for me. And,
thank you so much, Jeff. Have a great rest of your day, and hopefully we'll see you back at GroupBy at some point.
Oh yeah, sure. Thank you. I appreciate it. I guess somebody needs to enable the next speaker.
Yes, I can see Etienne is already on the call.
You should warn him that he's going to get thrown off.
Yeah, I think he's actually a panelist already. So I think, okay. Yeah, I think we're all set. We have about 7 minutes left to the next session. So if you want to hang out, Jeff, feel free to do that. I don't see any more questions, but in case there's anything, you can also take a look at the chat yourself.
Yeah, thank you very much. And thank you for moderating. And I told you, as a moderator, I'll take care of you. I'm hoping there won't be very many questions.
You're
So,
easy to moderate, so we're good.
thank you.
All right, let's see. I'll share my screen again so we can go back to our housekeeping slides.